All right, let's look at 13 and 14. I'm given these two polynomial functions, and they want me to completely factor them, but then also determine the solutions. So I have f of x equals x cubed minus 2x squared minus 21x minus 18. The first thing I notice is that my degree of this function is a 3. So that means I need 3 solutions, 3 factors. I need 3. So let's start by plugging my equation into my calculator. So I'm going to hit table, clear out what's ever in there, and I'm going to type x cubed minus 2x squared minus 21x minus 18. I'm going to hit enter, 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 enter. And again, I'm looking for all the y values that are 0 because those are my x-intercepts or my roots or my solutions. So 6 is one of my zeros. What else do we see? -1 is another 0. And then at -3. So I'm going to come over here and I'm going to write my zeros are -3, -1, and 6. Since I looked at my equation, I saw I only needed 3. I actually don't have to do any work because I already have all of my solutions. So I can come down here and put -3, -1, and 6. To get the factored form, all I'm going to do is take the opposite sign. So the opposite of -3 is a +3, so x plus 3. Opposite of -1 is a +1, so x plus 1. And the opposite of +6 is x -6. And those are my answers. Let's try 14. So 14, I have f of x equals 3x cubed plus 13x squared minus 11x minus 5. Again, my degree, the highest exponent is 3, so I need 3 solutions, 3 factors, 3 answers, 3 zeros. I'm going to take my cool calc, go to table, and I'm going to type in my new equation. So I have y equals 3x cubed plus 13x squared minus 11x minus 5. I'm going to hit enter, 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 enter. Again, looking for when the y values are 0. So here's my first one, -5. I have another x-intercept solution at 1, 0. And if I keep scrolling through the calculator, I'm going to find no more. So I'm going to come over here, and the zeros that I got from my calculator are 1 and -5. I do need 3. So what I'm going to do is use synthetic division. I'm going to use my first 0, which is 1, which is going to go in my box. I'm going to write the coefficients. So I have cube, squared, 1, none. So I'm going to have 3, 13, -11, and -5. So 3, 13, -11, -5. I'm going to drop my 3, and now I'm going to go multiply, add, multiply, add. So 1 times 3 is 3. 13 plus 3 is 16. Go back up to my box number of 1. 1 times 16 is 16. -11 plus 16 is 5. 1 times 5 is 5. And then -5 plus 5 is 0. Remember, you should be getting 0 as your remainder because this 1 is a solution. All right, so I can come down here and put 1. I'm going to take what is left over, which is this 3, 1 degree lower than x cubed, which is x squared, plus 6x plus 5. and I'm going to do synthetic division again. But this time I'm going to do it with my other 0 of -5. So my -5 is my box number. And my new coefficients here are 3, 16, and 5. You cannot go do your original function. I'm going to drop the 3, and now I'm going to multiply, add, multiply, add. So -5 times 3 is -15. 6 plus -15 is a +1. -5 times 1 is a -5. And 5 plus -5 is 0. Again, you better get 0 there because -5 is a solution. And that's part of the factor theorem. Now I'm going to take my leftovers. So here, I originally started with the cube. When I took out the 1 solution, I got x squared. And now I've taken out the -5 solution. So I'm going to go 1 degree lower than a squared, which is just x. So I'm going to have x plus 1. To figure out what that actual solution is, I'm going to set x plus 1 equal to 0. And I'm going to subtract 1 from both sides. So I have 3x equals a -1. And then divide by 3 on both sides. So x equals -1/3. So there is my third solution. And that's why it didn't show up in the calculator, because it's kind of that fraction, messy decimal. Now let's go write my factors. So the opposite of +1 is x is -1, x minus 1. The opposite of a -5 is x plus 5. And I'm not going to do x plus 1/3. I'm going to come back up here, and here's my factor, 3x plus 1.